Tracing an epidemic. The goal of this lesson is to demonstrate how an epidemic spreads and how to find the carrier. In this lesson, the class will participate in a mock epidemic that spreads throughout the class undetected. Afterwards, the class will use an indicator to determine who was the carrier, who was infected, and how the disease spread. Pre-lesson setups. Before starting the lesson, write the following vocab words on the board: epidemic, bacteria, viruses, protists, prions, indicator, and carrier. Refer to these vocab words as they come up throughout the lesson. To prepare for part 4 of the lesson, place 8 1-ounce cups on top of the laminated numbers 1 through 8. Pour water into cups 1 through 7 until they are 1/3 full. Pour 0.025 molar NaOH into cup 8 until it's 1/3 full. To prepare for part 5 of the lesson, you will need to fill enough 3.5 OZ cups about 1/3 full of water so that each student has one. Fill another 3.5 OZ cup with NaOH. Make sure that students do not see you do this. Part 1. Introduction. To introduce this lesson, lead a discussion about what causes diseases. Make sure you mention all of the following causes: bacteria, viruses, protists, and prions. More information about each of these and the diseases that they cause can be found in your manuals. Also, talk to the students about epidemics and how they spread. In your discussion, make sure you define the word epidemic and mention a couple of the more well-known epidemics such as the bubonic plague, smallpox, tuberculosis, AIDS, and the Ebola virus. Details about each of these epidemics as well as how they spread can be found in your lab manuals. Part 2. Steps scientists follow to test for a disease. Discuss with the students the steps that scientists follow to test for a disease. Make sure you explain and discuss each step in detail. Don't simply read from the manual. When you get to step 3, discuss with students the concept of positive and negative controls. Positive controls are groups where a positive result is expected. In this case, a positive control is a sample from an infected person. An infected person will be expected to test positive for whatever is causing the disease. Positive controls show that the test itself is working. Negative controls are groups where no result is expected. In this case, a negative control is a sample from an uninfected person. An uninfected person would not be expected to test positive for the disease. This ensures that there is no effect when there should be no effect. Also, explain to students what an indicator is. Tell them that in this experiment, they will be using the indicator phenolphthalein. Be sure to describe the properties of phenolphthalein, which you can find in your manuals. Part 3. Testing for a disease. In Part 3, you will be setting up positive and negative controls. For this part, you will need 1 bottle labeled uninfected, 1 bottle labeled infected, 1 1-ounce dropper bottles of phenolphthalein, 1 cup labeled uninfected, 1 cup labeled infected. Have the students empty the liquid in the bottle labeled infected into the cup labeled infected. Empty the liquid in the bottle labeled uninfected into the cup labeled uninfected. Ask the students if they can tell the difference between the two liquids. Both liquids should look the same and they should not be able to tell the difference. Add 1 to 2 drops of indicator to each cup. The infected cup should turn pink while the uninfected cup stays clear. Discuss these results in the context of positive and negative controls. In the case of the cup with the sodium hydroxide, the infection is present, making it a positive control test. So now we know that whenever we add phenolphthalein and the solution turns pink, then there is an infection. The cup containing only water did not change color and was the negative control test. So now we know that whenever we add phenolphthalein and the solution does not turn pink, there is no infection. Part 4. How does the disease spread and become an epidemic? A VSVS member should copy the exchange chart from the manual onto the board, while another VSVS member selects 6 student volunteers. You will be using 6 student volunteers and 2 VSVS members for a total of 8 people. As the students come up to the front of the room, hand each one a cup containing liquid and the corresponding tag. Save cup 8, the infected cup, for one of the VSVS volunteers. Have the students line up in front of the classroom facing the other students. Then have them exchange the liquids according to the chart on the board. In order to exchange liquids, have one student pour all of their liquid into the other student's cup, then have the other student pour half of their liquid back into the first student's cup. After the students have finished exchanging, tell them that cup 8 was the infected cup. See if the students can deduce which students should be infected by looking at the exchange chart on the board. Then add the indicator to determine if they are correct. Repeat this process with the second set of exchanges. After the second set of exchanges, there should be 4 infected people. Explain to students that the number of infected people doubles with each exchange. Part 5. The disease spreads. In this part, students will participate in an exercise that demonstrates how an epidemic spreads. Explain to students that they will be simulating an epidemic. Make sure you have an even number of people. Use teachers and VSVS members as necessary. Give all of the participants a cup. Make sure that a VSVS member gets the infected cup. Before exchanging, have the students pour out a small amount of their liquid into the 1-ounce cups on their desks. Have the students exchange the liquids in the same way they did in the previous part. First, have them exchange with their neighbor, and then have them exchange with 2 random people, preferably someone sitting far away. This prevents the disease from staying localized in one part of the classroom. Part 6. Patient 0. Add indicator to each cup to see who is infected. Add indicator to the small cups of the infected students to locate patient 0, which should be the VSVS member. Part 7. The cure. Explain to students how diseases can be stopped, then add 0.2 molar HCl to the cups of the infected students to cure them.